And if you've been a regular here, you know that we do talk with an expert almost every week, where we bring in one person from the field of heritage, archaeology, conservation, or anthropology to you, and we try to make it more widespread as to what we're doing in our little labs and in our little lives, which are far removed from the public eye. This is one of our public archaeology initiatives. If you've been involved with speaking archaeologically at all, you would know that speaking archaeologically is majorly a public archaeology venture, where we try to take in students, teach them about heritage, and hopefully propel them towards a career in archaeology, heritage, conservation, anthropology, art history, and other related fields. So joining us today is Carola, who I met last year in a museum where a dear friend of mine happens to be a curator. And this was an open thing going on where you could come and you could talk to the conservator working on metal conservation. And that's how we met. And since then, we've been trying to sort of figure out a date, settle on a time, and then do this for speaking archaeologically. In a minute, my colleague Simran here would be introducing Carola to you. But those of you who are joining in, just a few housekeeping rules from my end. A, please make sure that your mics are at all times switched off while the talk is going on so that the speaker doesn't get affected. B, to ensure that you have good bandwidth wherever you are in the world, try to keep your camera switched off throughout the talk. C, use the chat box feature to post in any questions that you have as and when you have them. And if you're not able to do that, please go back to the WhatsApp register group and post in your questions that you have that you would like us to take in the end. Carola has very kindly said that she's open to interactions and she'd love to hear from you. So at the end of the session, if you're able to raise your hands, unmute, and come on the screen and have a conversation, we encourage that today. Just let us know that this is something you'd want to do. You want to use the raise your hand feature that is at the top in your chat boxes, in your Microsoft Teams boxes. So with that, I think we can start the session now. We have finally exceeded the time for the talk. And Simran, the floor is yours. And Carola, thank you so much for being here. Welcome, and we look forward to the talk.
Thank you so much. And we are very excited to have Carola with us. Carola is a metal conservator who specializes in historical and archaeological metals. She has previously worked with the Fishbourne Roman Palace, as well as the Novium in Chichester, the Brighton Royal Pavilion, and the Worthing Museum in Sussex. At present, she is working with Historic England, as well as MSDS Marine Labs. We are very excited to have you on board with us, Carola, and the floor is all yours. So if you want to share your screen, and we are very excited to learn from you.
Okay. Sorry about this. Okay, so I'm gonna start doing my. Can you see that?
We've lost your screen, I'm afraid, so we just see a blank screen.
Yeah, me too. I'm so sorry about this.
That's all right.
I'm
That's
gonna go
technology.
slideshow from the beginning. There we go. Can you see that?
Yes, we can.
Okay, fantastic. Right. So, hello, everybody. So, as you know, my name's Carola. It's wonderful to be here today. Thank you for attending. And I really hope that there's something in this talk which you find interesting. So, just to introduce myself, I'm an archaeological metal conservator, which means that my focus is on conserving archaeological metal objects, and I work on objects which are both from land and sea environments. I'm also an investigative conservator, which I'll describe in more detail as we go through the presentation. And just a brief into my background, I studied a degree in glass making, so that's stained glass. I was more sort of interested in arts and crafts at that point. Then I worked with metals as a sculptor, and I moved into a job as a theatrical prop maker and scenery builder. And eventually I came around to studying conservation of metals. So I did a 1 year postgraduate course in the UK, and then I went on to do a master's. And I now work jointly for Historic England, which is the public body responsible for protecting Britain's historic archaeological environment. And I also work for a private company called MSDS Heritage, which is a maritime archaeology company. So overall, my work is to conserve objects from protected shipwrecks and also from terrestrial archaeology digs. I also collaborate, as Simran said earlier, with smaller museums to help care for their archaeological collections. But so overall, really, I'm interested in preserving objects for the public to see, not really in private collections. In this presentation, I'm just going to give you a basic introduction to metal conservation, how we do it in the UK, to talk about some methods we use, and I'll illustrate this by using some case studies from my work. And when I've finished, as mentioned, we've got time for a Q&A so I can answer your questions. So I understand that quite a lot of you are students. There may be things here that you're already familiar with, or maybe you do things differently. I'd love to hear how you might do things. So, an archaeological conservator. So, as an archaeological and investigative conservator, I have three main objectives. Firstly, is to conserve objects of cultural significance. And by using some of the techniques that I'll look at today, my task is more or less is basically to stabilize and prevent further deterioration. Secondly, it's to investigate the object. So this is to uncover technical details, to reveal the surface of the object, anything we can find out about the object. And thirdly, it's to really to retain as much original material as possible associated with the burial context, and to provide information to specialists who will interpret the information and place it within a cultural context, and thereby it enriches the public's knowledge of the culture which created the object. Even if this culture is no longer in existence, it helps to get us to understand how people in the past lived. The objects I work on, and these are all objects on the screen which I have worked on recently, they often come directly from archaeological sites. They're sometimes covered still in soil, and I use a wide variety of methods to remove the soil, to stop the object from deteriorating, and to investigate the object. And I collaborate also with researchers in different fields and specialists to interpret the object's significance. I have to excuse me, I've been a bit of a cough recently. So the best thing I like about my job is that it is like detective work. As a conservator, I'm often the first person after the archaeologist to fully see and understand an object since it was buried. And my work, or the work of a conservator in my position, can reveal detailed decoration, the materials that were used, any manufacturing techniques. We can often reveal tool marks, and even ancient writing, as we'll see later. I'll show you something that I found. And these are really important details to enhance our understanding of the people and the culture that created the objects. We've got some objects here on screen. So one shield boss, which is the center of a shield, obviously completely made of corrosion now, but that was quite a difficult jigsaw to put together, and parts of it still missing. The thing in the center is a copper sieve, a Roman sieve that was found by some children in a riverbed. It was filled with coins. And on the right there, that's something called a wrist clasp. That's Saxon, so it's about 1500 years old, and it goes around the cuffs of a shirt. Was found in a burial ground along with many of the other objects which I will be showing to you. So it's also my job to identify and to preserve the remains of any organic materials which may be part of or have come into contact with a metal object. So as you probably know, iron corrosion specifically can expand up to 8 times if it's in really damp conditions. And it can preserve the materials it touches by penetrating them and creating detailed impressions or casts. For instance, a bone or wood knife handles, textiles which were touching jewelry, or textiles which have been things have been wrapped in, or wood and leather from shields and sword sheaths. And these are called mineral preserved organics. So the things you can see on the screen there, they are no longer actually textile. This is corrosion in the shape of the textile. So while the textile itself has deteriorated, and as you can see on the right, the corrosion from this stud, it was a shield stud, has expanded into a wooden shield, preserving the shape of the wood. And recognizing these can be quite difficult because when you receive an object, it's covered in soil. It's really tempting to kind of wipe everything off, but it's these details that can really tell us so much more. So for instance, you can see that textile there on the left. Well, the 3 examples on the left, they're all very different, and these are from a Saxon burial ground, so that's AD 5 to 600. A couple of hundred years after the Romans left the UK, Saxons from Germany and kind of Western Europe, Northern Western Europe, came into Britain, and they also brought with them these crafts and these skills. And we can see from this textile just the intricacy and the beauty of the textiles that they used. So that's really the role of an archaeological conservator. And I'm just going to move on briefly to understanding metal. So commonly found archaeological metals include copper, iron, lead, silver, gold, and bronze. And bronze is an alloy. And probably all the metals made in antiquity are alloys. So this means a metal which is a mixture of metals. It's extremely rare to find an object which is made of a pure metal. Even nowadays, when we have gold, your gold jewelry, it's got some copper in, it may have some silver in. And the reason that metalsmiths create alloys is that it improves certain characteristics of the main metal. So for instance, as you can see on the slide, bronze is a copper alloy, and copper alloys is any metal where the main ingredient is copper. They may have other metals in. So bronze is a copper alloy. It's made with copper and tin. The tin adds hardness and corrosion resistance, which makes it really ideal for tools, weapons, and armor. And here you can see some more examples. So brass is copper and zinc. Gold usually has some copper in. Steel is iron and carbon, and the addition of the carbon makes the iron much stronger and more durable. And often lead is introduced because lead has a much lower melting temperature than most metals. So it means that it can be melted and cast much more easily. One of the main things that a metal conservator comes across, well, the main thing is corrosion. So understanding how metals interact with their environment is crucial because the interaction leads to corrosion. And corrosion is typically triggered by oxygen, moisture, and or salts, where the metal begins bonding with these elements to create corrosion, essentially. So in dry environments with less moisture around, metals can be less prone to corrosion, meaning that in dry environments, objects are often far better preserved than they are in damp conditions. So you can imagine in the UK, everything we retrieve from the ground is corroded to some extent, to a large extent. You may have heard the word patina. This is still technically corrosion, but it's really used to signify a more desirable type of corrosion, which is just a very thin layer on the surface of a metal, which has essentially sealed it and it's not actively corroding the metal away. The metal's not deteriorating. It's just kind of a patina, we say. And that's not always the layer that we want to remove. So here we can see the different types of metal that you will generally come into contact with. Iron reacts strongly with oxygen and water to form iron oxide, or various types of iron oxides, which we know as rust. Lead reacts with moisture and volatile gases and produces a white or yellow corrosion. So if you've got lead objects in a case with, for instance, oak, anything, or the case is made of oak, exudes kind of volatile gases that will deteriorate and corrode the lead. Copper reacts with carbon dioxide and moisture, forming green, blue, and brown patinas, which you may be very familiar with. Silver tends to react more with pollution, among other kind of airborne environmental things, forming black, orange, or purple patina. And gold is the only metal which doesn't corrode unless it's alloyed with a significant percentage of another metal, in which case it's the other metal that's corroding. So on the far right here, you can see there's a gold foil applied over a copper alloy, and you can see the green corroding through the gold foil. So each type of metal corrodes differently, depending on its composition and the environment that it's buried in. And as conservators, it's our role to study these processes so that we can recognise them and slow them or even stop the corrosion to preserve the artefacts. Okay, so okay, 1 second. So, as mentioned, the goal of an archaeological conservator is to stabilize the objects and also to uncover historical information, but without destroying original material. So it's a fine line. And this is why each step of your treatment of an object should be thought through very carefully before you start, before you remove any corrosion, before you treat corroded surfaces. One of the processes that you need to go through to preserve an object is to really observe the object, to look at it and try and understand what you're looking at. So in general, when you clean an object or you surface clean an object, you're trying to reveal what's called the original surface. And this can be tricky with a corroded object. The original surface will have the details or any decorative features or paint, and it may be covered in corrosion. So for instance, if you decide to remove all the corrosion on the surface of an object, you might discover that the original surface was held within one of those layers of corrosion, and you might have removed an important detail, or you might even discover that there's no actual metal left in the object. You've just removed all the corrosion, and there's just a tiny metal core in the middle. You've removed all of the details, and we often find this with metal detectorists. For instance, they'll find coins or jewelry, and then they'll to try and remove the corrosion, they'll soak it in an acid overnight, and what they find is it takes away all of the corrosion, but it also takes away any detail, and they're just left with a kind of an object that's been essentially, we call, stripped. So if you can see on the left here, there's only a small metal core left. This is actually a cross section through a bronze hairpin. So it was quite a large object, almost like a knitting needle. It had a decorative sort of point at one end, and it's been cut through the center. And excuse me, you can see there's only a tiny bit of metal, and it's mainly made up of corrosion products. So you can see in the cross section of the coin on the right hand side that it's completely made of corrosion. So the surface details and how we would identify the coin are held in one of those layers of corrosion, and the details will actually be made of corrosion. So you've got to work as a conservator really slowly. We generally work under a microscope if we're working on small objects like this. Just it's a really slow job, but it's better to go slowly to not miss any of those little details. So you can see really how if you removed all of the corrosion, you would risk also changing the original shape of the object, or you might discover that parts of the object were even held together by corrosion. And, you know, if you don't observe your object before looking at it, these are some of the mistakes you can make. Oops. Okay, sorry, just having a little bit of trouble with my navigation there. Right, so if we move on to some of the most commonly used methods and techniques used by metal conservators. So firstly, observation. If we look at analytical assessment, before deciding on any treatment, we need to understand the structure and the composition of the object. And for this, we can use several methods. Visual assessment. So firstly, take time to really look at the object. You might do this by eye or under magnification. You need to identify any corrosion, any old coatings, any damage to the object, any weak areas. You might be able to see some decoration peeking through some of the corrosion, or organic impressions like the ones we saw earlier, like textiles or leather. And these details can be really key to understanding the object and then planning your treatment. So if you see in the middle at the top there, that's it's a copper alloy buckle. You can tell it's copper alloy because of that green corrosion. But the kind of yellow that's in between all the decoration there, that's an old coating. So in the past, someone had coated it with a wax. The wax deteriorates and it becomes porous and kind of white and yellow. And so we can tell here that needs to be removed. Below that is the back of a brooch. And by looking at it under magnification, we can see all these tiny little micro cracks that just weren't visible. It just shows us how delicate this object is. And on the right here, this is a brooch, a Roman brooch, and I can see that after cleaning the surface, I can actually see the tool marks there. So if you're familiar with metal smithing and making metal objects, I would know what tools the artisan was using and how the process which they went through. So more analysis methods, X-radiography or X-rays. Sometimes you can't see the surface of an object clearly. The object might still be covered in soil or corrosion. Parts of it may be hidden inside the object, or you want to understand more about the object itself. So the construction of the object. In these cases, X-rays can reveal hidden details, as you can see here. So you might spot inlays made of different materials, or voids which are shown by dark patches, and they indicate weak spots. So you'd know not to put pressure or to be careful of those areas. You could see intricate designs, and these insights can help to guide how you approach the object. So on the right-hand side here, this is it's a casket, it's an iron casket, and I knew that there was a locking mechanism on the inside of the lid, but I couldn't see it. Like it was covered with a metal panel. So this is absolutely the best way to understand taking an X-ray and how it can help. And then you can see the coins there. Actually, they didn't need to be cleaned. We can, the specialist was able to identify the coins just by looking at the X-ray. So we didn't need to any interventive treatment with these coins at all. And then the thing in the middle, that's actually a Roman knife handle. So you can see the studs around the edge that I think it was a sheath actually, and the white areas are inlays of a different metal. So that would be a silver that's inlaid into an iron base. So another method you might be familiar with is XRF, X-ray fluorescence. This tool, which you can see on the left there, it's kind of like a kind of futuristic gun. It fires X-rays at the object's surface which then return an energy reading. So they displace atoms, and then the displacement returns an energy reading, which is specific to certain elements. That then tells us which elements are present in the area which is being analysed. So, for instance, it can tell us whether an object that looks like gold really is gold, or whether it's just a gold-coloured alloy like brass. And if you know that, then you know how to treat the object. So brass has copper in, and you'd know that you can or can't use certain treatments. You treat it differently than you would if it was gold. So on the right here, you can see that's a typical spectra that you might get as a reading. You can see the peaks there. That's where the higher energy reading came back, and they're labelled there. So lead, arsenic, iron. Right, so if we go on to some of the tools, the hand tools that we can use, and these are called mechanical methods. So these involve using tools to clean an object and to reveal the original surface that we talked about earlier. So we often use hand tools such as scalpels, brushes, and wooden tools. And I tend to also, many conservators also adapt everyday objects for specific tasks. So you could use a pin. I've recently used thorns to clean a very soft gold object. And even, old credit cards, you can cut to certain shapes for particular, to clean particular areas. So air pressure tools, that's another tool that we use. We use a compressed air gun to remove soil or surface residues. So it sprays a fine jet of air, pressured air, onto the surface of an object. You can also include tiny abrasive particles in the air. We might typically use aluminium oxide or very finely crushed walnut shells. And this is for gentle cleaning of hard crusts or thin corrosion layers. An air scribe, which is the tool in the center there, is the tip of this tool vibrates to break apart very hard corrosion. And it's quite an aggressive tool though, so it should only be used in the appropriate circumstances. The object there is actually a coin that was retrieved from a shipwreck, and you can see there that it's covered in what we call concretion. And then bottom right there is a type of ultrasonic tool. So these use high frequency sound waves in a liquid to loosen dirt and corrosion. And they're frequently used by jewelers for cleaning jewelry and other intricate objects. But because it's a very high frequency vibration, it's not suitable for fragile objects. So for instance, you wouldn't put a fragile, objects that's made of, say, corrosion into an ultrasonic bath, because it would just completely disintegrate. Again, so as you can see, before using any of these tools, it's really essential to really carefully consider whether it's appropriate for the object's condition. One of the main things is caution. So whenever you're doing a treatment, apply caution before you do anything, because most of the methods that you'll be using are just not reversible. So another key approach in metal conservation involves chemical methods, which we use sparingly. I personally, my approach is to use as least interventive methods as possible. But sometimes chemical methods, or the use that the object's going to go to after you've treated it, just mean that actually this is the best way of moving forwards. So a common application is corrosion control and removal. Using the right technique, chemicals can dissolve corrosion, or they can create a protective layer by bonding with the surface of the metal to exclude other environmental factors, or to neutralize acidic deterioration processes. So protective coatings are another common treatment. A clear lacquer that we use can be brushed onto an object to seal the surface, and this obviously protects it from moisture or handling. And where an object is powdery or unstable, as you see you'll find quite a lot with copper alloys. They become powdery and mineralized, we call it, as through age, and you might need to consolidate that powdery area. And we use a solution that penetrates the object and then hardens, preventing further deterioration. Finally, solvent cleaning is a well-used technique. I'm sure that you're familiar with this. So by applying distilled water or alcohols or other solvents onto the surface of an object with a cotton swab, you can carefully remove dirt, loose corrosion, old coatings, or other residues. So I'm going to now look at some case studies to show how these different techniques can be used. Okay. It seems that this isn't working very well, which is a shame, but essentially this was working perfectly when we looked at it before. But this is a Saxon brooch. So this again was from the burial site where the other objects that I worked on. And it's a large brooch. It's made of a copper alloy, and it was I received it within a clump of earth. So it was essentially hidden from me, but we'd taken an X-ray, so I knew what to expect. And I used, you can see the tools that I used there were like this air puffer, brushes, soft brushes, and essentially without touching the object. So I've got a thorn there in my hand, just being as careful as I possibly could with this object. Oops. We need to the next one. Okay, so so when I had removed all the soil, as you can see there's kind of 4 stages. I realized that there was a fragile, a really thin gold surface underneath all of the soil and the layers of corrosion. So on the top left there, you can see the soil. On the top right, I've cleaned away some of the soil. And on the bottom left there, I used a weak solution of formic acid on cotton wool swabs to carefully start to dissolve that corrosion. I found so firstly removed the green corrosion, and then as you can see underneath, there's a really unusual blue corrosion layer, and you can see that there's gold leaf underneath. Then on the bottom right, that's with all of the corrosion removed. And you can see that there are these applied silver areas, and the green that you can see that is still there is the base metal, which obviously contained copper because it's green. It was probably what we would call a bronze, and it's mineralized, so it's turned into this compact copper corrosion product. So there's actually no bronze left within the object. And this is so a closer look. This is where observation comes in. A closer look at the silver strips under magnification showed it. I could see some deliberate markings, so they weren't just like scratches. So I had a closer look, and we can see that there's a type of writing that was used at the time, which is 1500 years ago. The writing's called runes, and it's a particular type of writing that I'm familiar with from studying these cultures. So I knew what I was looking at. I obviously photographed it, and then this went to a runes specialist, and we now have an idea of what it said, which was something like, a good man called Godin gave this to a woman. So it's really, really nice to kind of just see this similar gifts of jewelry, and just bringing you really close to these people whose objects you're working on. So this is an ongoing project. I would be very grateful if you could not share pictures of this online, because the project hasn't been published yet. or actually any of these, but it's an ongoing project. So this is one of 5 similar chests which was recovered from the Roosevelt shipwreck, which sank in 1749. I'm not the only conservator, so there were several conservators who worked on this project as a whole. So and it's, as I say, ongoing. Upwards of 4,000 objects have been recovered from the shipwreck. But this is just one of the objects that I was personally responsible for. So this is the one I'm going to talk about. So firstly, when it was recovered, we could see that it was a chest, because even though it was covered in concretion from the seabed, which had become very hard and hard crust coating the object, the shape of the planks was still visible. So you can see on the left there kind of what sort of state it was in. Also, it's very black and orange, which shows us that this is iron corrosion. So it tells us that there was iron objects inside the chest. And as you can see, and we talked about earlier, the iron corrosion has expanded. So the wood was no longer really there as wood, and it had been preserved by the corrosion, as we talked about earlier. So the wood was no longer there. It was in a terrible condition. We removed it, and it did go to a wood specialist to be identified. But we could see that the contents were iron sword blades, and they had all corroded into this big heavy block. And it was then my job to disassemble the block, and it took me around 3 to 4 months to disassemble each blade. There were around 100 blades in the block, and they were placed alternately in layers, with the tang and the tip alternately placed. So once the block was disassembled, we could see that they're technically saber blades, which means they've got that curve. They had no handles, presuming because this meant that you could fit more into a chest. And so I used an ultrasonic pen and hand tools to surface clean the objects individually. Throughout the whole process, they were stored in large tanks of a solution which removes the salt from them. So salt or chlorides have to be removed from anything recovered from a marine environment, because, as you probably know, salt causes rapid corrosion and deterioration. And that's a really long process. It's done by osmosis, and we keep on regularly monitoring the chloride levels in the solution and changing the solution. So currently they've been in the solution for just over a year, and we are right now moving on to the next stage, which would be drying them or dewatering the objects. And again, so this is done by chemical methods. It's done by brushing on a solvent which displaces the water. They'll then be moved to sealed containers with a desiccant, which we use a desiccant called silica gel, to completely remove any remaining water. And after that, we'll coat them with a clear sealant to protect them from any atmospheric water, because they're then going to be displayed in a museum. So the next slide is also a video, and apologies if it doesn't work properly. I don't know if you can hear the audio there.
We can't know, so we'd appreciate if you talk.
So I'm just going to talk you through it. So what I'm saying is that on that side, I'm just about to remove that sword from the layer. I'm just saying how careful I have to be with it, because I'm going to start at the tip end. Was the easiest place to start, and the tang end, which is the handle end, was much thicker, so it was less flexible. So as you can see, it's very dirty. All that black was concretion and iron sulfide. And I'm using a steel, we call them dentist tools there, just to kind of edge underneath that tip there, and try and create a bit of air and release it from the concretion that's kind of penetrated inside the chest and inside the layers of the swords. And so then it's just a case of gently using these wooden and plastic tools to slip in between the layers and try and just release it from the concretion. So I'm providing support there at the end, because as I release it going further down, then I just need to make sure there's no pressure. Using plastic and wooden tools at this stage instead of the metal tools to reduce any danger of scratching the blades. And the blades were still fairly flexible at this point. They were corroded on the surface, and the edges, for instance, the blade was quite brittle, the blade edge. But there you go, it's managed to release it from the block. The blade is quite fragile here, so you just have to be quite careful of how you lift it up. And you can see the amount of concretion that's still attached to the blade there. So there were 100 swords in the chest, and once each one was released, it went into the solution. And then I had to go over each one, surface cleaning using the ultrasonic and some of the hand tools. Next case study. This isn't actually something that I worked on, but it's still very commonly and so the sort of item that I do come across very often will be things that are found in graves, often weaponry, or just knives. Everyday people, just everyone had a knife to just, it was a handy kind of tool to do things with, but this is actually a spearhead. So in this case, the X-ray there on the left shows us really how the object is constructed. And we can see how the metalwork thins out in one area, and also it's not very visible here, but we could tell the kind of hammer marks. We could see hammer marks on it. Also, you can see that it's in fragments. So the fragments were then surface cleaned and a corrosion inhibitor was applied. And then the different fragments were then also consolidated, because as you can imagine, this very fragile and friable surface there. And then the conservator actually has done an amazing job there of reconstructing the object so that it's easier for us to understand, and when it's displayed, it's easier for the public to understand. That one works, that's a pleasure. So finally, I've got this, it's a Roman hoard. We called it a drinking hoard. It was found by a metal detectorist, and it was brought to me in a block of earth, brought to the lab at Historic England. So they brought it in what's called a soil block, because they didn't know how fragile it was, and obviously the work that needs to be done to it may not have been the kind of areas or tools to do that on site. So it was brought to me in a soil block. So I then removed all the earth from the exterior and, as you can see, the interior, using hand tools very slowly, and revealed this bronze bucket. So the bucket had a lead pedestal, and because the bucket had sort of it had become more fragile over the 2,000 years that it's been in the ground. So it had kind of collapsed and created these kind of cracks in the side of it. So, and inside, as you saw there was a jug and two cups placed inside each other and all neatly placed inside the bucket. Residue analysis was carried out on the soil inside the objects, but there was no evidence of any food or drink, sadly, because that's kind of really interesting and you can find out things like that. So it was obviously placed in a hole. There was no body or any other things in the surrounding area, so this could have just been hidden for any reason. The bucket's got some damage, so as you can see, it was cracked and collapsed. But in general, it's actually in pretty good condition. So then part of the job of the conservatory, or my job anyway, was to create this kind of packaging that supports the object so that it can be stored safely, it won't collapse any further, and that's then how it went to the museum. So I hope that has told you a little bit about my job. And that was my final slide. And I think that we're going to have some questions now. I'd be very happy to answer any questions you have. I'm going to stop sharing my screen now.
Thank you so much for that, Carola. We have quite a lot of questions, and I have few in the group, I have few in the chat box here, and I want to know how people want to do it. So those from the research wing, I was wondering if you're able to unmute yourselves and show yourself. So Anya's got questions clearly. Anya, can you show yourself on the screen, please, and ask them yourself? Because that's the sort of thing that Carola would like today.
I'm happy to do it however people want to do it. So,
good evening, ma'am. Would it be fine if I just unmute my mic for now and ask my questions?
Go on, go ahead.
Okay. First of all, thank you so much for the talk today. It was really nice to hear about the different conservation techniques and also to see the video of you conserving different types of materials. So the first question is related to how metal artifacts are displayed in museums, because I am personally very interested in museum studies. So my question is, what are the ideal temperature and humidity conditions for displaying archaeological metal artifacts in museums? And how can museums maintain these conditions effectively?
So, okay, so that's quite a sort of involved question. I can answer the question, but I'm also going to direct you to a resource. If you search historic, I think English heritage storage of archaeological metals, there's a quite a long PDF that you can download that has each metal, archaeological metals, it has each metal, and it's got exactly what you've just asked. But for so archaeological metals will corrode, especially iron, just given the chance. Essentially, it's a very reactive metal, as you know, and they should be really. So iron should be stored in below 19% relative humidity, which is really low, and it's kind of a lot of museums can't really achieve that. So the way that so you could either have that in a temperature an environmentally controlled case, but the way that I don't work in a museum, I work in an institution that conserves the objects and then gives them to museums. So it's not really my field to know, I'm sorry, about museum display, but I can tell you about temperatures. The way we do it is an object will be stored in what we call microclimates. So we'll conserve the object, we'll create a supportive storage for it, and we'll put it in an airtight box with silica gel in and a relative humidity strip so that we can monitor it. Obviously, in the UK, it's a very damp environment, so any metals are really going to corrode. I think archaeological irons, off the top of my head, is below 19% RH. I think copper alloys is maybe below 30%. With silver, it's less about the relative humidity and more about pollutants in the air. So if you have silver in an environment which is kind of it's, for instance, on open display, probably it will develop a black, orange, or purple patina, which can look really unsightly, and that's why we try and coat silver. But for temperatures, unless it's really extreme temperatures, doesn't really affect metals. What you don't want is extreme fluctuations of anything, because then you might get movement in the object. But I would direct you towards that resource, the English Heritage storage of archaeological metals, and that's got like specialist advice.
Got it, ma'am. I think I have found the PDF and I will go through it after the talk ends. I will
I
like
hope
to
that
ask
helps.
one more question. So, in your answer right now, like you mentioned, that there are a lot of specifications that we have to keep in mind while dealing with different kinds of metals. So, this question is actually more related to excavations. I wanted to know that at what stage of an excavation do conservators become involved? Do they work alongside archaeologists from the beginning, such as advising on excavation techniques that can minimize damage? Or do conservators usually handle artifacts once they have been recovered and once they are in labs which may be far away from the sites?
Yes, I love this question. Ideally, everybody would work together. So the way that we work at Historic England is that a site and a dig is planned, and you at that planning stage you've got scientific advisors, you've got conservator, you've got archaeologists, and any other specialists who they think are relevant, all kind of planning the design project. It's very unusual for a dig in the UK anyway to have a conservator there. Um, and usually there will be someone called a finds expert who is the kind of the link in between. And we have a book called First Aid for Finds, and I think there's a new version of it coming out, but you should be able to find this kind of advice online. It basically tells you how to pack the objects you find on site before they then go to the conservator to a lab. So there's also, if you remember the drinking hoard that I showed you, that was what's called block lifted. So when they find something that might be too fragile to be completely excavated, there's a way of digging around the object, putting something like a board underneath it, wrapping the whole soil block in maybe cling film or various different ways of doing it, and then taking all of that, and then that goes to the lab, so it can be what's called micro excavated in the lab. So ideally the advice of a conservator is should be involved really at the onset of the archaeological project. But usually they might call a conservator on site if there's something really specific or unusual that they found that the finds expert might want the conservator there for. But there are lots of different stages in the UK of how that sort of process happens. And usually the conservator is just in the lab and we will get the objects. Does that answer your question?
Yes, ma'am, that answers my question. Thank you so
Yes,
much. And I think other
my
people have
pleasure.
questions as well, so I'll open the floor for them.
So we have one question in the chat box from Ramya, who says she wouldn't be able to stay for the entire Q&A, and she wants to know, in the Roman bronze hoard, were you able to trace any organic material?
No. So the only we did we did kind of residue analysis of, well, I didn't, we worked with scientists within the institution, and there was no evidence of any food or anything organic that had been put in there, but that obviously was a consideration because there could have been any sort of deposits that would be information that would tell us more about the context of the object. They could even have been, human remains, they could have been ash, it could have been a burial, but there was nothing. What we did find, though, was that, should have got a photo of it for you, but around the jug. So the objects inside had evidently been packed with straw because the copper corrosion had extended out. It had kind of become more voluminous, and you could see the impressions of the straw. So this was something that I showed to, we've got work with an archaeobotanist, and she was able to identify the type of, I'm saying it's straw, but it was some kind of grass type, something like straw. It's not my area. And they could tell roughly maybe what time of year it had been buried, or what type of vegetation that actually was. So it wasn't actual vegetation or organic residues, it was the impression on those on the wall, on the sides and the edges of the objects.
That's very interesting. Thank you so much for that.
Really was.
Another question we have is from the audience, and this person would like to know, can you suggest some methods for preserving and conserving silver and gold jewelry? And I'm presuming it's in post-excavation context as well. So if you find jewelry and it's fragile, what do you do with it?
So archaeological jewelry I can tell you about. Gold doesn't corrode, so you will find gold and it will be just as beautiful as the day that it was buried or even created. You have to be very careful with it though, because it's very soft metal. So I worked on something recently that was a very high purity gold, and I only used a soft brush and a thorn. So we get these thorns bushes, they're quite long, and you can insert the thorn into kind of a small hand tool like a vise. And I worked on it under magnification, and the tip of the thorn, you use it gently, use the brush and the air puffer, then you just avoid scratching the object. Gold really isn't a problem. Silver, it really depends on what the burial environment was. Silver tends to go brittle over time, because the metal that it's alloyed with, which is often copper, will corrode and it will leach out of the silver, which means that it will leave where it was inside the silver will be like a void, little microscopic voids, which makes the silver very brittle. I've worked on archaeological silver recently. It can be found in various states of decay, sometimes very fragile and just crumbling, and sometimes actually still quite beautiful. Typically, it will have a black corrosion layer, like a thin black corrosion layer, which is very difficult to remove, and you shouldn't rub it, because the silver itself is quite a fragile metal once it's been underground for a long time. I also wouldn't use any chemicals on either of those metals. Really, you have to just really employ caution, because there could also be, I don't know if you're talking about a specific piece, but there could be any other decorations. There could be enamel, which is glass, and that glass could be very fragile and crumbling. It's just every piece is different. So caution, I would say caution.
I think related to that, we have another methodological question, which goes, how do you decide between CT scanning and X-radiography while working with objects? So which do you prefer and when?
So this is not my area. Where I work, we have, so I do sometimes do the X-rays. I did the X-rays I showed you, but I don't work with CT scanner, so I can't give you any advice about that. I usually work with small objects where an X-ray is enough for me to understand what's going on with the object. CT scanning is, I wish I knew more about it, so I'm afraid I can't really answer your question, but yeah, sorry, I can't answer how you might decide between those two. I'm sorry.
That's all right. I think that sort of answers it for the person asking, that because we've got so many methodologies, I think everybody has a different stage of involvement depending on what kind of object it is. Also, the size really matters in conservation. That's something that we always talk about. If it's bigger things, there's a different person doing it. If it's a smaller thing, there's sometimes more than one people doing it. So it also changes hands depending on how much conservation it needs. We have another question which goes, what difference in erosion can be seen, or how do factors of erosion differ between artifacts found on land and in underwater contexts?
By erosion, do you mean if they mean deterioration? Again, it really depends what the terrain, so what the environment is. So as you saw those swords, if a single sword had been left on the surface of the sea, it would have just so 300 years it's been under the sea, single sword would have just gone backwards and forwards, the waves, and bashed around, and there's obviously the corrosion happens with available oxygen, and it would have just corroded and be non-existent. But what happened with that chest is that the concretion, the sand, and all of the vegetation and the mollusks and everything created this case, like concretion and casing, like that completely excluded oxygen. So inside, the object suddenly gradually just became very stable. The environment inside the chest became very stable. The black is a sulfide, it's an iron sulfide. So that develops when you've only got these kind of microbes that are producing sulfides that then react with the iron. When and that means that the objects kind of, if they're in a sealed environment, they can be very well preserved. Sometimes, so if you've got an iron object, it will create this concretion around it because of the iron extending outwards, like we spoke, and then the concretion could be a small object, like maybe a knife blade, something like that. It's created this big concretion, and then the knife blade itself has deteriorated; it no longer exists. But you can see, but if you crack open the concretion, you can see the void where it was. So you might get not an object, but a complete sort of the void with a beautiful shape, so you can tell what that object was. Obviously, different metals corrode at different rates. It depends also, like if there's, like I said, about the available oxygen. So if there's an area which is very choppy underwater, lots of kind of waves and stuff, then things are going to be very badly corroded unless they kind of they get covered by sand, and that's a different thing again. So when we find wreck sites that are covered, if you think about, I don't know if you're familiar with, for instance, the Vasa in Stockholm it's VASA. It's an incredible shipwreck. You should search it. It sank almost completely in silt and became clay that's sealed around it. I think it's 500 years old. It looks like new. That was kind of quite an unusual thing. On land, again, it depends on the environment. So we have things like bog bodies, which were placed, I guess, when they were dead in these bogs, which then have a specific anaerobic environment, and they're completely well preserved. You can even tell their hair and their wrinkles on their faces, and they've still got their stomach contents and all their clothes and everything. But in maybe acidic soils, you wouldn't get that at all. You wouldn't even get the trace of a person. So the thing with metals is that they are very reactive to their environment, and you can get all sorts. It's such a wide range of degradation and corrosion that you're dealing with that it can be a bit tricky sometimes to remember like what the treatments are for different things.
We have a lot of people who are interested in your personal experiences now. So I have a lot of questions that are just going to and fro about what is the most interesting damage or corrosion you've encountered, or the most challenging one that you personally sort of think of as something that pushed you to do a lot more than you would normally done.
So the swords was one, because I think when I first saw that, I just looked at it and thought, I have absolutely no idea how I'm gonna deal with this. The first picture you saw of me taking the wood off, I just had no idea how I was going to deal with it. But I think one one of the things I always think is there's always a way. Okay, I don't know how, but there is always a way. Gosh, so many difficult things. So there was the swords. Also, recently I've had an object that was recovered from a ship from a marine site. Nobody knew what it was. It was kind of like a bell shape, but we used XRF analysis on it and found that it was almost pure zinc. Did an X-ray, and I wish I had a photo for you. I can't really find one at the moment, but we did an X-ray, and we saw that it had lots of beautiful inlaid patterns on it, but the object was just completely corroded. It was so corroded that it just looked like it was made of stone. I kind of I sent the photos of this object to as many people as I thought I could, and eventually somebody said this is the base of a hookah pipe and it's bidri ware, which is really uncommon to find in British waters. And it was actually a colleague, someone that I studied with, who now works at the Victoria and Albert Museum in London, and he had conserved a beautiful set of like bidri ware, but I could not find anybody internationally who could tell me anything about zinc corrosion rates in salt water. So also, I couldn't see the inlay visually. I could only see it on the X-ray. And I started very, very carefully. So the object, it come out the sea, so we needed to desalinate it. So it was being stored in this particular solution that desalinates objects, but I didn't know if the solution was going to corrode the zinc. So I had to do all these fill in all these charts to kind of understand that it's all about electrochemistry. Finally, I sort of decided I was going to start trying to gradually take away some of the top of the corrosion. So I revealed some of the inlays, but what, as you may know, with bidri, the very, very fine silver inlays that are not put in with glue, they're put in mechanically. So as soon as I revealed them, they were just falling out, and it was silver, so it was very brittle. And in the end, we've decided with this object that we can't do anything to it that would be of any benefit to the object. So it's going to be displayed as it is. It's desalinated at the moment. It's going to be displayed with this thing. It just looks like a piece of rock almost in a weird shape, but with the X-ray next to it, so that people can see what is underneath the corrosion. And sometimes that's just even more interesting than just seeing a perfect object. So that was very challenging. Yeah.
That sounds very challenging, and bidri ware is something that's closer to home for us because we have
Yes.
an extensive bidri ware area of handicraft. And like you said, it's very challenging even to work with it, even to own one in your houses. I have some. Just to have that as a showpiece in your house is a nightmare. So even if it's made
Maybe
today,
I should have spoken to you.
even if it's made today, there's nothing you can do. You can't dust it properly. If it's got real silver in it, now they've started doing other metals as well. So it gives you a silver kind of effect, but they don't really use pure silver so much. If they do, it's really expensive. But even with other metal inlays in place of silver that might give the same effect, including steel and tin sometimes, it's a nightmare to have.
Imagine.
And one of the things that
Yeah.
I wanted to personally ask you is, this is something it's so ironic. We were talking about it last night, Simran and I. Have you ever encountered something that has already been cleaned acidically, which is not recommended for metals, and you've had to sort of look at it again and sort of redo the conservation bit where...
So, unfortunately, once someone has stripped something with acid, there's nothing you can do, because essentially they've got, let's imagine a coin. There are so many videos online with amateur people who are trying to help, saying, oh, this is how you can clean a coin. You kind of rub it with toothpaste, or you put it in Coca-Cola overnight, or you you know, anything. Essentially, what they're doing is they're saying things like tomato ketchup. All these things that
Oh,
they're
yes.
using has got vinegar in, and vinegar, as you know, is an acid. Okay, but it's uncontrolled, and also the tomato ketchup, for instance, it's also got sugar in, it's got all sorts of other things which will eventually will should just penetrate the object, and it's just really, really bad idea to use any of those things that you're not in control of. So unfortunately, if someone has already done that, there's really not much you can do because the evidence is gone. And I've never actually had to, well, I think just because there's nothing you can do, I've never worked on anything like that. But um, I have been at sort of finders events. So in some museums, they will have like a Saturday where you can come in if you found some objects, and I can give people advice. And people have come in and with things and said, "Oh, I did this to this coin. What can you do?" And you kind of have to just say, "You can't do anything. It's gone now." So yeah, sadly, that's the
We've had a
answer,
lot of
really.
that. I think a while ago we had a student who was taught in her university, could you imagine? And this is an archaeology student being taught at her university to clean copper coins with ketchup. And she comes back and she says, well, this is what we did at college today. And well, you're not supposed to do that. And if
Mm,
they're copper coins and they're historical copper coins, if you use ketchup in it, like you said, it's got acid in it. It would,
yeah.
I mean, I had some really bad coins in my own collection as well. And I went, well, let's do this now to these really bad coins, which are already beyond help. I know there's nothing that can come out of it, and there's no information that we can get out of it because they were already treated with an acid before I had attained them. I had acquired them. So I said, well, do use everything that you see on the internet, including toothpaste, vinegar, um, lemon, and salt, which is one of the most ridiculous ones that I've found online, which is rubbing a coin or anything metallic with lemon and salt. So do all of
Yeah.
that and tell me what it gives you. And what it does is it gives you, sometimes with the coin, it gives you a 15-minute window where everything appears really clear for a bit. And then 15 minutes later, it's even worse than it was when you started with it. And that's, I think, a very useful exercise if you've got spare
Yeah.
artifacts which are not valuable, essentially, or
Absolutely.
if you've got coins that are common context, for example. I think that's a very valuable exercise to have with the general public also. We were talking about how public can be initiated into these things that we do in lab environments and privately as archaeologists and conservators.
Yeah.
So sometimes just to contextualize something like that and show them the damage it will do makes more sense, because otherwise they're repeatedly taking these coins under the tap water with toothpaste or vinegar or ketchup. And that, like, I know of people who've done this periodically for age-old coins that they've had for quite a bit, until I said, well, you're probably going to lose it. In a matter of years, it's just going to be a plain disc of metal and nothing else.
I think it's also, this is where understanding the basics of material science and metals and corrosion, just the very basics, comes into play because um, as most coins are alloys, or most metals are alloys, and if you add them into a solution, the more reactive metal in that alloy is going to be the one that dissolves. So what you'll do is you might add a chemical to, for instance, brass, and this is a good experiment to do. If you add a chemical, if you add an acid to brass, or just drip some on the surface of a little bit of brass sheet, underneath it will just go pink like copper. And what's happened is that it's dissolved zinc. So you're actively dissolving parts of the metal that you're supposed to be preserving.
I think somebody once brought a coin to me, which was supposed to be a Victorian silver coin from India. So it was an East India Company Victorian silver coin before India became a proper colony. So you still had the East India Company. They were issuing silver rupee coins. And it was such an interesting coin because they'd used acid to clean it. And like you said, the underlying metal, which would it would probably be a copper alloy. So the copper survived, and the silver, only the bits that the acid did not hit was still silver, and the rest of it was all copper. And they went, well, how is this a copper coin? Because it's clearly an original coin. It's got all the inscriptions and the carvings which show that it's the original. But how is it that only that bit is silver and the rest of it is copper? Because it's been treated with acid. And that's what's happened. Silver's reacted and dissolved, and all we're left with is the underlying copper. So that's one interesting thing that sort of always gets to me when people don't really realize, like you said, the basics of material chemistry, and then they treat it with all sorts of things that come handy, and then wonder what happened to the coin it was supposed to be, or the metal that it was supposed to be.
Know your science.
Yeah, it's a difficult world we live in, with specifically with YouTube telling us so many things in terms of how to take care of an antique sword you might have, or an antique piece of jewelry you might have, and how to clean that. I think it just makes things difficult for people who are actually looking at historical artifacts.
Yeah, absolutely.
We have no more questions, which brings us to the end of the session. Thank you so much, Carola, for today. And I'm so grateful for finally making this talk happen with you, because we've been waiting to do this with you for so long. I think I wanted to do it almost immediately when I met you at Worthing Museum, and I said, well, could you do this talk for us? And then for the longest time, I think Simran was trying to intermediate and find out the right dates and everything that worked for you. So thank you so much for doing this. Thank you to everybody who joined in. And Simran, I would like you to take over and say a few words as well.
Again, thank you so much for the talk today. I feel I say this on behalf of everyone that we really learned so much. And there's just so much to explore now, so many things to sort of think about. And just the fact that we were talking about just before the talk also started, I really love how this also, in a way, bridged a gap between what happens really when we're looking at artifacts and conserving them, and people who are just maybe visiting museums and looking at them and trying to wonder what really goes behind that object and its story. So thank you so much for helping us understand a little bit about these objects and about metal conservation in general. And I feel like we would love to host you again in the future, and we would love to hear more about your projects as well. And thank you so much, everyone, as well, for joining us today. We would love to see more of you in the future as well. And again, as stated in the beginning of the talk as well, if you would love to sort of work with us, work towards this common goal of making archaeology and heritage accessible and contributing more to the knowledge, please do contact us. We would love to have you.
Yes, and thank you for having me. I just wanted to say that if anyone's, I do post a lot of my projects on Instagram, and you can just find me by my name, just searching my name on Instagram. I'd be really happy to answer any further questions if you wanted to contact me through there. So yeah, thank you so much for having me, and good luck in all your projects, and thank you.
Thank you so much for being with us. And we'd, like Simran said, we'd love to have you back again, maybe with something more details about a particular project that you're doing or that you've already done, and that'd be all right to go in the public domain. I think it'd be wonderful to hear more. I couldn't help but notice the Pulbara sieve that you've conserved.
Oh yeah,
which was in one of your slides, and that's one of the first things when I first went to Worthing Museum, James literally fished it out of the display case, going, hold that in your hand and look at it, and this is what we have, and this is how it came out. And a bunch of boys found it while playing at a ground, and it was full of coins. And now, like I said, I was just there 2 weeks ago. It's in pristine condition thanks to your efforts, the things that I saw you doing when I first met you.
thank you. Okay.
Thank you so much. We will bring this session to a close now. Thank you, everybody, for joining us today, tonight, where you are, and we hope to see you again. Thank you very much. Thank you again, Carola.